Awesome. So here is section D, part 2, questions 4 and 5. So both of these kind of go together. So we're going to do both of them all in one video. So the first question says, if there are 4.02 times 10 to the 23rd molecules of N2O in a sample, how many moles are there? So number 4 is just going to be a mole conversion. So let's go ahead and start with that. So it's 4.02 times 10 to the 23rd molecules of N2O. So from molecules to moles, we do have one direct conversion, so we can go ahead and do that. Molecules up top means we're putting molecules down on the bottom. And then we can go ahead and put moles right up top. For this conversion, we're going to use Avogadro's number, so we're going to say that 1 mole is equal to 6.02 times 10 to the 23rd atoms, or molecules, or particles. Let's plug that into our calculator. I know that's the toughest part. So when you plug it in, the most important part is that you're using the parentheses. The other thing you want to use is that EE key or that exponent key. So if you have one of the black calculators that I give in my classroom, you're going to use the key that's just above the 7. If you have a graphing calculator, you're going to have to hit that second function. So when we plug this in, we're going to say open parentheses, plug in that top. So 4.02. We got to get to that EE function or times 10 to the, plug in 23 as is. Don't add multiplied by or 10 or to the power of, anything like that. Just like that, close parentheses, divided by open parentheses for that bottom. 6.02, second function, EE or the exponent times 10 to the 23rd, close parentheses on that. Hit enter and we have our number of moles. Again, a good practice is, if you're ever writing something in moles, you want to go to that third decimal place out or to the thousandths of a mole. So we'll say 6, we'll round it up to 8 moles of N2O. Awesome. So that's your answer for question number 4. And then question 5 says, using the data from number 4, calculate the pressure of a gas if it occupies 27,025 centimeters cubed of space at 38.0 degrees Celsius. So it's talking about this specific quantity of gas. So since it gives us the number of moles, that means that we're going to be using that combined gas law, or sorry, I misspoke, the ideal gas law. So PV equals nRT. So for pressure, volume, moles, ideal, or gas constant. So let's go ahead and pull out all these variables. The first one we can pull from question 4. We have the number of moles, 0.668 moles, N2O. We have our gas constant, 0.0821 liters ATM per Kelvin mole. We'll keep going. Calculate the pressure, so that's what we're looking for. 27,025 centimeters cubed. So anything cubed is our volume at 38.0 degrees Celsius. All right, so there's a lot going on in this problem. The first thing we got to remember is that all of the units have to match our R values. So we need to get to liters, atmospheres, Kelvin, and mole. So let's do our easier one first. Celsius to Kelvin, add that 273.15. So we'll say 273.15 plus 38. We'll get 311.15 Kelvin. And then for our volume, this one's a little bit trickier. So for this one, you have to know that 1 centimeter cubed is equal to 1 milliliter. And then you're going to need a secondary conversion as well, that 1,000 milliliters are equal to 1 liter. So we're going to have to do 2 conversions to get our volume into the correct unit that we want. So we're going to say, let's set it up like we always set up our dimensional analysis. So centimeters cubed up top means it's going to the bottom. We can't go directly to liters, so we're going to go to milliliters first. It's a 1-to-1 conversion. Milliliters up top means it's going to the bottom, and we can go straight to liters. Just like we talked about a long time ago in Unit 1, the larger one gets the 1. So 1 liter has 1,000 milliliters. Let's go ahead and plug it in. So we're going to do 27025 times 1 times 1 divided by 1,000. And we get 27.025 liters. Alright, so there is our liters. And now that it is in liters, we are going to be able to plug that in. Again, let's go ahead and manipulate that equation. I'll rewrite it over here so we see it. PV equals nRT. We want pressure by itself. So let's go ahead and manipulate the equation so we can get pressure by itself. So once we plug everything in, we just plug it into our calculator and we're good to go. So we're going to divide both sides by volume. So it cancels. Rewrite it. nRT over V. Now that pressure is by itself, we can go ahead and plug in everything we have. Make sure you're plugging in those correct units. So pressure is equal to N, the number of moles, which is 0.668 moles. R, our universal gas constant, 821 liters ATM per Kelvin mole. And temperature, 311.15 Kelvin. Divided by our volume, which we found to be 27.025 liters. We plug that all into our calculator, so we say open parentheses, plug in all the top, 0.668 times 0.0821 times 311.15 divided by 27.025, and we get the pressure is 0.63 atmospheres. Awesome. I know it's a lot, but as long as you go step by step, do one conversion at a time, you'll be good to go.